Utilization. As previously mentioned, the fuse plays a vital role in providing overcurrent protection. In today's market, numerous devices, including circuit breakers, claim to fulfill this crucial task. So what truly sets the fuse apart and distinguishes it as a standard option? Well, the fuse boasts exceptional characteristics in terms of cost effectiveness and response time. These remarkable qualities make it exceedingly difficult for other protective devices such as circuit breakers to compete. In fact, when compared to the fuse, circuit breakers are almost 10 times slower in their response and considerably more expensive. Nevertheless, as with any technology, the fuse does have its limitations, and in this case, it lies in its reusability. When a fuse blows due to excessive current flow, it necessitates replacement with a new one, which can potentially diminish its cost effectiveness and ecological sustainability. This aspect becomes particularly relevant when safeguarding circuits that contain devices prone to frequent large current spikes, such as unstable motorized systems. In such cases, a circuit breaker emerges as a more suitable candidate for effectively handling electric systems of this nature. However, it is important to note that a fuse truly shines when employed in circuits designed to draw a stable amount of current. It finds its optimal application in circuits comprising devices that are both sensitive to overcurrent and expensive to repair, such as delicate electronics. While all types of fuses serve as reliable overcurrent protection devices, each variant differs slightly in design to best suit the specific circuit in which it will be installed. So, to expand further on this comparison between fuses and circuit breakers, imagine you have an unstable motorized system which you are protecting with a fuse. Every time the system draws a large current spike, the fuse will blow and it will cause downtime, and you're gonna have to replace the fuse, which diminishes the fuse's cost effectiveness. A circuit breaker would be a much better candidate because of its slow response time and because when it trips, you can just turn it back on and the system can continue to operate. On the other hand, if you have an electronic controller which draws a stable amount of current, the fuse which would be a much better candidate than a circuit breaker since it will be faster in its response time, protecting the expensive electronic controller when something goes wrong in its circuit. Among the wide array of fuse options available in the market, the cartridge fuse stands out as the most familiar and commonly encountered type, predominantly found within electrical panels. Recognizable by its cylindrical shape, it features metal casings at both the top and the bottom, which serve as the terminals for the fuse. Enclosed within the cylinder is a metal strip that connects these terminals together, ensuring the flow of electrical current. The cylinder itself can be constructed from either ceramic or glass material. Glass fuses are highly favored by professionals due to their transparent nature, which allows for visual inspection to determine if the fuse has blown. Conversely, ceramic fuses possess the advantage of withstanding higher temperatures, providing enhanced durability in demanding environments. Moreover, within the cartridge fuse category, numerous variants exist, each tailored to specific application requirements. Examples including slow blow and fast blow fuses, which differ in terms of the material and design of the metal strip they incorporate. Additionally, fuses are also classified based on the type of current they are designed to handle, including AC, DC, and high voltage variants. In the case of DC and high voltage cartridge fuses, their cylinders are typically filled with sand or oil. This unique feature serves the critical purpose of extinguishing the arc that forms inside the fuse when it blows. effectively preventing any further damage. However, such arc extinguishing measures are unnecessary in low voltage AC applications. Installing a cartridge fuse can be achieved through insertion into a fuse holder or by soldering it onto a printed circuit board, also known as PCB. Specifically within electrical panels, a specialized type of fuse holder is utilized as it can be easily mounted onto the panel's mounting rails. On the slide, as you can see, these specialized fuse holders are the ones to the right. The holder itself comprises two screws, one positioned at the top and another at the bottom, both directly connected to the fuse's terminals. These screws play a crucial role in connecting the wires of the circuit. While the process of opening the fuse holder may vary slightly between different brands, it typically involves manipulating a plastic piece that unlocks the holder, providing access for the insertion of one or two fuses. Additionally, in most cases, the holder conveniently includes a slot for a spare fuse, allowing for quick and effortless replacement in the event of a blown fuse. This feature ensures minimal downtime and facilitates efficient maintenance procedures. Furthermore, it is worth mentioning that in a configuration of industrial panels, a phase or positive wire from the electrical source is connected to one of the screws, preferably the top one. From there, the electricity is then distributed to one or more devices through the other screw. Such a setup primarily employs cartridge fuses to safeguard critical components like power supplies, electronic controllers such as programmable logic controllers, also known as PLCs, as well as the coils of relays and contactors. As you can see in the slide in front of you, all of those are examples of cartridge fuse holders. The ones to the right are used in industrial panels, while the ones to the left are mostly used on PCBs. The ones to the right have screws that connect wires to them, while the ones to the left, the fuse holders are soldered to wires or PCBs. Overall, while the market may offer an array of options for overcurrent protection, the fuse stands out due to its exceptional cost effectiveness and rapid response time. Although it does have its limitations, particularly regarding reusability, the fuse excels in circuits that require a stable current draw and protects devices that are sensitive to overcurrent and that are costly to repair. With the cartridge fuse being the most prevalent and recognizable type in the market, its various configurations and installation methods ensure versatility and ease of use. Whether in electrical panels or other applications, the fuse remains an indispensable component, providing reliable protection to critical electrical systems and sensitive electronic components.